Afternoon or good evening to some people. And before I introduce Dr. Connor Bryant, I just want to say welcome to, I think most of our viewers tonight are from South Africa. We might have some international viewers as well from various other countries that we operate in. And Connor, before I introduce you, I just want to let the people know that you and I actually haven't met in person. And we've obviously only met online. So it's been quite phenomenal during this COVID period as well, in terms of what can be accomplished, in terms of people we can meet and information we can gather. So just a brief history, many of the doctors in South Africa obviously know SciVision Medical and know our history in terms of laser dentistry and also x-ray. So when this whole COVID thing came around, we're quite aware of the ability of laser energy to destroy bacteria and virus and fungus and things like that in the mouth. So for those of you who don't know, Connor is also a dentist, so he understands terminology I'm speaking about as well. He's not just an engineer or something like that. He's actually a dentist as well, so he understands what happens in the surgery and the aerosols and so on. So because of our laser background as a company, I started looking at, well, if the lasers can work so well in the mouth, how, and they destroy particularly virus and bacteria, then surely there's a way that the lasers can work in destroying virus potentially in the air. So then I started looking into, well, what wavelength would be effective, and looking into all the UV lights. And then I started watching some of the webinars, and Connor, you did some of those with the doctors in the UK, and I was part of those webinars and many others, and then started to gather information and really looking deep into how does the laser energy, or how does light actually destroy virus? And that's what obviously became quite interesting for us. And then we came on your system and I listened to one of the talks that you gave, and was really quite fascinated by the way your unit works in terms of capturing the air and also the amount of air it can capture, and then going through the different filtration systems, from the HEPA filters to the pre-filters to the carbon filters, and then into the UV light. And as far as I know, it's 250 nanometers that you guys are using. And then I looked into the nanometers because that was quite interesting for us when we work with laser technology, is the absorption. When you shine a specific wavelength, what is it absorbing it? So if we're talking erbium laser, it's absorbed mainly by water. If we're talking diode laser, it's pigment, it's the color of the tissue, and it's different ways of absorption through with the water laser would be thermomechanical ablation, because the water absorbs it, vaporizes whatever it's aiming it at. And then with diode lasers, we're looking more pigment. And that's what kind of made us quite fascinated. And then looking at, well, how much energy do we need to shine a certain wavelength at a certain bacteria or virus to actually, for lack of a better word, vaporize that particular virus that we're looking at? And then I started looking at your machine and saying, well, you're using 24 watts of power. What is the distance it must carry? What is the square centimeters? Then I started calculating and doing many of my own sums. You can see in many of the documents here, I was taking your machine and doing all my sums and saying, well, if a virus needs 1.2 millijoules to 1.7 millijoules per square centimeter to essentially vaporize it or destroy it, how much energy are you giving in your machine? So I took your watts and looked at it. I thought, well, this is amazing. You guys are going way over what's even needed. So it was really fascinating, and that's kind of why we looked at the system and thought, well, it kind of fits with our company in terms of lasers and energy, and we're talking about nanometers and things. So that's why we are so happy to have found you and your system that works so well, and specifically that your system was designed for the dental surgery and not just for for general purpose or general use. Of course, it can be used for things outside dentistry, even to greater effect. But with the high risk that's associated with aerosols and so on, potentially that your unit is actually designed for the surgery makes it even more attractive for us. So without further ado, for those who don't know Connor, Connor is a founder and co-owner of Bryant Dental in the UK, who developed the system, and he's the overseer and product designer, so with development, working with a range of engineers and scientists, and together with his meticulous attention to the delicate balance between function and aesthetics, he and his team bring this industry-leading technology to dentistry. Connor also holds an honours degree in dentistry from King's College in London. So that's kind of my little brief introduction. And Connor, we've had some numerous chats, and I think you've seen too that we're really interested in this technology from a science perspective as well and how it works. So now I'm going to hand over to you, Connor, and thank you so much for putting time aside to talk to us, because I know you guys have been inundated with manufacturing of this machine to supply clinics and hospitals, and obviously the dental surgeries are number one on your list as well. And we are in your production waiting list to get the first 50 units into South Africa, anticipated hopefully early July. So thank you very much for that, and for giving South Africa an opportunity to be part of this system of yours. And we've already got quite a few doctors who've ordered numerous of the systems, and we're quite excited to get the first ones into South Africa. So thank you, Connor. Over to you.
Well, thank you very much for that introduction. So we're here in the UK, and we have one of the units, the DentAir units, just in the corner here, which is currently on. So you'll quite happily be able to hear me talk. So you'll find that it's not very intrusive. To tell you a little bit more about my company, we're a team of 45, and around about 50% of us are dentists. So anyone that you would interact with on a day-to-day basis, they don't just know everything about dentistry. Most of their time is spent actually in people's mouths, and then 2 to 3 days a week they work with me. So it means we have a lot more inside knowledge, not just in transferring that knowledge to you guys, but also in developing new products. So what we do with most of our products when we come up with a new idea is we buy all the competitive products. So in our research laboratory, we have 9 different machines that are very good for purifying air. And we take them and we say, what is good about this unit? What is the thing that's allowing them to have a place in the market? And we take that from there, and we take all of them. And then we look at it from a dental point of view and say, what parts are really needed and what parts will make a difference to dentistry? And what we came up with this is DentAir. And it's a combination of technologies. So it's not just relying on HEPA, like some of them. It's a combination of a pre-filter, and then a HEPA filter, and then a carbon filter, then a titanium dioxide catalyst, then UV, and then air ionization. So quite literally, every technology that you can use for purifying air, we have in this unit. And it's also a lot smaller than some of the comparable units, because we're very, very good at sort of concentrating technology and using them together. So you mentioned previously about the amount of wattage needed to eradicate the viruses. And we came up with similar figures to yourself. And we've massively over-engineered it in terms of how much energy we're giving those viruses, so we can completely ensure the eradication in the air. So we're talking around 40 milliwatts per centimeter squared, rather than 1.9 or 1.7, which is required. And on top of that, we have a titanium dioxide catalyst, which actually coats the inside of the carbon filter, which gives us a huge surface area. Now, one of the downsides to using titanium dioxide with UV is it produces ozone. But actually, because it's impregnated inside the carbon filter, it means we're absorbing that ozone at the same time. So we're well below the limits that are set out by the EU and USA standards.
Okay.
And what it means is we can then create a unit that's going to be very quiet, because it's never running at full capacity. We are able to clear a room up to 120 cubic meters comfortably with this machine. We found most surgeries will be sort of 30 to 40 cubic meters, which means you're going to be turning over the air every 3 to 4 minutes. So most of the time, it'll only be running 20 to 30%.
Yeah. So I saw a study, I think it was by Boston University, they're recommending a dental surgery should be turned over something like 15 times per hour. Is that correct? Is it also the basis you guys are working on?
So the basis we're working on is the Public Health England guidelines. Public Health England states that in a surgery, you should turn over the air 5 times an hour. With our unit, you can easily exceed 15, 20 times. So we generally have 2 to 3 times the throughput of any machine of a similar size. So generally we find it's more 1 unit per chair. You're very, very rarely going to have to put multiple units into a single room.
Earlier today, you showed me some sort of a fogger machine that you're blowing towards it, and I don't know if you're going to do that demonstration today or another time. Yeah, but that was quite interesting, the way it was able to capture that amount of of air. And so a typical surgery, it's just say surgery is 3 by 4 meters, 2.5 meters high, somewhere around there. I think that works up to about 30 cubic meters or something like that. And that's also the critical thing to work out with these units. It's not just square meter, but it's cubic meter, because the ceilings are obviously higher than in some rooms. So where would you typically put this unit? Would it obviously be kind of in the corner of the surgery, on the floor as it is? And I know we discussed you possibly making some sort of a trolley system so it can be moved from room to room.
In terms of where to place it, what we've actually done is created technology in there which moves the air around your room. So rather than you having to put it in a very, very specific place, the machine will create that airflow within your room. So what it does is it draws air in the bottom, 360 degrees around the unit, and then shoots it out the top. So actually what you're doing is creating what is like a very large donut of air within your room. So it's pushing clean air out the top and then bringing the dirty air underneath. So as long as it's about 20 centimeters away from each wall, you'll get that kind of convection of air going around your room. Okay. The other thing that it has is something called reactive air kinetic technology. So this uses lasers to scan the air to detect particles and also volatile organic components. And with that, it gives you an air cleanliness score and will adapt the throughput of the fan according to how contaminated your air is. So when it detects, say, an aerosol generating procedure, the fan will increase in speed and deal with that, what's going on in the air. And I can actually demonstrate that now. So for example, this is a particulate generator, so it will generate 1 million particles per meter cube. And the machine will deal, I mean, generally bad air is 75, so we're talking magnitudes more. And what I can actually do is I can, of course it's decided to turn off. Give me 1 second, sorry, it's just heating up.
Okay.
So what this will do is completely overwhelm the machine, but you'll find that it's still able to cope. So what you'll notice is it will draw all of the air into the machine, but no smoke will come out of the top. And you can see my lovely scrubbery wall being blown around by the air at the moment. So this is on maximum at the moment, and you can still have a conversation over it.
Yeah.
On maximum, it will be around about the same volume as an air conditioning unit. So now I can blast the air into this thing pretty much consistently, and you'll see it drawing the air straight, the particles straight in. So if I press this, you can then see. So it's literally just absorbing absolutely everything.
That's pretty
and then
impressive.
As I stop, you'll notice in a second the unit will change, and it will react to that. So it's increased the speed of air through the unit. Okay. And it will clear the room very, very quickly of any of the contaminants in the air.
So just in terms of the noise, you said it's equivalent to sort of an aircon. I think I read somewhere about 40 decibels. So it's like a sound of a fridge.
Yes, exactly.
Yeah. Okay.
So you can see now it's gone red. I'm not sure if you can see that on the camera. So it's now reacting and they're going to drive through the air a lot more quickly to decontaminate that air. And you'll see it will quite quickly go back green again. If I zoom in here. So it's already gone back to yellow, and in a second it will go green once it's dealt with that amount of smoke. Wow. It'll go back to green already.
So this comes with an app that you can download onto an Apple phone or an Android phone. Absolutely. And that app, and what is that app? Is that app ready to download yet or not yet?
It will be, we're just going through the final stages of testing between countries at the moment. But when the units are shipped, it will be ready. With that, you can monitor the air quality. It'll show you a graph of how your air quality differs through the day, not just the parts, but also organic components. So in some countries, they're doing air quality auditing.
I was just about to ask that,
and check your air quality. This will do it automatically for you.
Okay, so it's also good for, as you say, auditing, for record keeping and so on. That's actually quite an amazing tool. Then I know some of these HEPA filters, I mean, do you have to wash them or vacuum them out? Or they're totally disposed of when they, after their period of time, which we estimate, say, an average once a year or something like that? What happens then with the HEPA filters?
Yeah, so there's absolutely no hoovering or washing of these filters. We know with some of the competitor products, you have to do that once a week, but then you're relying on the filter in your Hoover not to push that, whatever you filtered out, straight back into your air. So we created to have a HEPA filter which is so much larger, So you can build up 6 to 12 months of use on a single filter, which is then replaceable. And I can actually show you how easy it is to remove the filter. You literally just turn the unit on its side, the bottom then unscrews, and you can take the filter out.
Okay,
and
simple.
Then also show you how large the HEPA filter is. So this is why you won't have to, unlike some of the other units, wash the filter, because it is so large. And then very, very easily, with standard PPE, you can put this into your standard clinical waste.
Okay, great. Then just in terms of cost, I know obviously you're thinking in pounds, and we've kind of taken what you told us and converted it into rand. Just by the way, we're about 22 rand to £1. So South Africa is a good place for you to come on holiday, because you can have a really nice holiday.
Absolutely. I think there's got to be an excuse for that in there somewhere.
So with the strength of your currency, so I've kind of taken your, and I think you spoke about close to £95 per year for the filters, for the two filters. And I think it was something like £46 or something for the bulbs, the lights. And if you estimate this to be taken over, I don't know, a 1 year period, but the servicing or changing these filters is dependent on the quality of air, I presume, that's coming through it.
Yes.
Okay. So it's not like a definite answer. You must change it every year. It depends on what's going through it.
Absolutely. So from the testing we've done, funnily enough, if you're in the countryside, we generally find that the filters get clogged up more because they're drawing a lot of pollen and a lot of external contaminants. Likely, if you're in the center of a city, you'll get a lot more pollution. So it's not just based on the dental stuff you're pulling out of the air, because this is so good at removing everything in the air. It's completely dependent on how much stuff goes into the filter. But it also means that if you do suffer from allergies, you won't have any of those in the room anymore. So you'll have a noticeable difference in terms of allergies. Okay.
Then I just see there's a question. Does the humidity influence the air cleaning? The humidity in the surgery?
The higher the humidity, the more coagulation of sort of particulates in the air you get. But because this machine is very good at moving a large volume of air, it won't really affect it too much. If you have a high humidity, you'll notice the fan runs sort of higher for longer because it has to do more work. But actually, because it's capable of 120 cubic meters and you're probably using 30 to 40, it's not going to cause a problem for you.
Okay. Then just in terms of peace of mind, I've had some dentists asking me, okay, and I've had to explain to them over the phone that a lot of science was putting behind in terms of the wattage of the bulb, the surface, how many millijoules per square centimeter we need to kill the virus and so on. So the air comes in, it goes through the filters, the HEPA filter, the carbon filter, the pre-filter, and then it also gets the UVC. So in terms of what can pass through, because from what I can see from all the scientific literature and so on, a virus in terms of particle size, I mean, it's pretty small. It's like got the numbers here, something like 0.01 micron to 0.4 micron, where bacteria is a lot bigger, talking 0.5 micron to 1.5 micron. And so if this is stopping 99.97% of, and also what I found out too, that the virus, because it's so light, it moves, instead of a straight line, which theoretically should go right through a 0.3 HEPA filter, but because it moves in a zigzag way, because it's actually lighter than most of the air, it gets bounced around. And there are attempts to come together with other virus and get clogged in the HEPA filter. But then even if we've got 0.03% of viruses that potentially still go through the HEPA filter, they then being pretty much obliterated by the UVC. So the chance of any virus still coming out the top of your unit is I mean, it's pretty much close to zero from what I can make out. Is that correct?
Absolutely. So HEPA filters are rated as a standard of how well they filter out 0.3 micron particles, because these are the most difficult ones to filter out. Actually, smaller particles have a higher efficiency of filtration with a HEPA filter, but it's purely a standard as to why everyone quotes 0.3. So 99.995% of the viruses will be filtered out, because the corona, for example, is 0.12. So most of that will be filtered out with a HEPA filter. But anything that gets past that then has to go through catalyzed UVC. So actually the viral load, if you will, at the UVC is very, very low anyway. And then we're massively overkilling with the amount of UV that we've got. So the chance of anything out of the top are very, very minimal. And So you've got multiple stages of removing anything from the air.
Yeah. And then from what I can understand too, the purpose of the titanium dioxide is to kind of go to organic organisms in the air and breaks them up into water and carbon dioxide. Is that correct?
So the titanium dioxide, first of all, produces a huge surface area, which allows it's a bit like slowing down the air against the UV. So the UV doesn't have to act upon the virus for as long if it's in the titanium dioxide environment. And again, with other chemical reactions, so it just speeds up the rate of chemical reactions. So any of your volatile organic compounds that you are breaking down, you're correct, will be broken down into water and carbon dioxide a lot quicker under the influence of the titanium dioxide catalyst.
And then the purpose of the ionization is essentially to go and create this negative positive field and then be attracted to some of the particles in the air, making them heavier, which brings them down to drop down either on your surface and use surface disinfectant, or otherwise obviously get sucked back in and go through the same cycle again.
Exactly, yeah. So negative, not just down because it's not affected by gravity, but it's affected to a positive or neutral charge. So any neutral. So most of this is dealt with within the machine anyway, because it will be charged and then attracted within the machine, because all of this happens in the UV chamber. So actually, we're not pushing negative ions into the air. There's not a lot of science to say that that's useful, but it's more about how it deals with things inside the UV chamber, the ionization inside the UV chamber.
Yeah. So pretty much from what I can make out and my limited knowledge on this, you guys are pretty much, you talk about the 5-stage filtration, and there's pretty much nothing left to really add to it from what I can see any other technology. And even the fact that you put the smart technology to actually monitor the air for you and give you clean air audits and so on, I think that's actually amazing. So now originally, I know you guys didn't develop this during the COVID time. It came on long before that because you were looking at something for dental surgery air. And so did you then increase something or improve something because of COVID, or was it pretty much always at this level of creation?
So we always look at other countries to see what they're doing in terms of dentistry, and we find there are a number of countries which are a few years ahead of what's happening in the UK. To take South Korea, for example, we're the main manufacturer of loupes in the UK, and our lenses are ground in South Korea. So we know what's going on very well in the dental world in South Korea. And they are massively well informed about air quality within the dental surgery. One of the studies I've seen say it's the second worst quality of air for any profession, because you're in a room constantly generating aerosols and not really allowed to have any sort of airflow through a window. So they make it mandatory to have some form of air purification in a dental setting. So we kind of looked at it and said, how long do we think it will be until the UK bring in something similar? So we started developing this unit. Mainly because we're sort of thinking about our own health. And when you think about the amount of people you come into contact with and your staff in general, if these people are just bringing in colds and flu, and you can remove those viruses from the air, that's going to be a huge benefit, regardless of all this COVID stuff going on. So that was kind of the way we looked at it. One of the things that we changed was the fact that everyone's really looking at viruses at the moment. And there was a little bit of people didn't really know what was happening if you're trapping some of the viruses in the HEPA filter, and they were worried that that was going to then be a problem. So we moved the UV to the inside of the HEPA filter and then created a peptide coating, which is antimicrobial. So you cannot have bacteria and viruses growing on the filter for 2 reasons. 1, the antimicrobial coating, and 2, the UV light is bathing those filters. So we kind of, as people got more educated to air filtration, we changed our design to make sure that we sort of put to rest anyone's concerns with a unit like this.
Yeah. Okay. I see one of our doctors in South Africa, maxillofacial surgeon, Dr. BLACKIE SWART, is just asking you would like to not ask a question to the chat, but actually come on. So Robert, if you are able to unmute Dr. BLACKIE SWART and let him ask some questions, we don't necessarily have to. So if you're okay, Connor, I'll just open up any verbal questions that some doctors might want to ask. Yeah. So we can just check. I don't know, Dr. Swart, if you are unmuted, if you can come on.
Hi, Brian. Brian, my question is, we're obviously looking at these technologies because we need them desperately. Because South Africa is only going into our peak now. And actually, the hospital that I am in is the epicenter of COVID in South Africa at the moment. We had 10 deaths last night. So this is not a question of possibilities. What I want to know is, what is your science behind that? And what is the tests? Because the test that I saw, which was given to me beforehand when I saw the product, was your test on bacteria, the effect on mites, and the effect on clean air. And unfortunately, I could not find anything on viruses, because the problem is there are very different degrees of HEPA filters. You get hyper HEPA and you get normal HEPA filters. And then it is the time in connection with the UVC, because we know both of them are very good at virucidal. But I would like to see scientific tests, because we are not talking about a possibility. I'm talking about a reality in my practice. And that's why this is very, very important for me. And I was looking at it, and it looks, all the products seem to be there, but I want scientific evidence. And the evidence that was given to me was not appropriate.
Yeah, absolutely. Very, very valid points. So previously, when we started working on this, which is why we already had the test for bacteria and particulates in the air, those are the tests that we put forward. So since Corona has come about, we've set in some other tests. The unit is currently being tested for viruses, so we should have those results in a few weeks. We're unbelievably confident, because we know that the UVC chamber in here alone has the ability to eradicate 99.997% of influenza H1N1 and the SARS virus from 2003. So when we're putting it in our unit with the addition of HEPA, the addition of carbon, the addition of titanium dioxide, we're very, very confident that it will pass those tests. Obviously, at the moment, no one can test against COVID-19, because you cannot cultivate that virus because it's illegal at the moment, because there is no vaccine. But as soon as any other tests are available, our unit is going through testing. But because it is all very new in terms of the virus, we are just in a queue to have that tested. But we believe we should have that in a number of weeks.
Because the Bronwyn test, also a very interesting scientific test, is when a virus like Corona, the SARS-CoV-2, which is between, you correctly said, between 0.6 and 0.15 of a micron, but that is unattached. Then it goes in that sort of circular motion. But as soon as you put it in an aerosol as an AGP procedures, that is not unattached anymore, because it binds with the water, and therefore the circumference is not 0.15 unattached anymore. So the validity of that is not true anymore.
Yeah, so with, you mentioned about the different types of HEPA. So what we have here is an H13 HEPA. So it is the best for its ability. Obviously, there are H14, H15 HEPAs, which go from being able to filter out 99.997 to 99.9997 or 99.99997. You get just 0.000 more, but it means that you're going to clog that filter a lot more quickly, and you cannot pass as much air through that filter because it's a lot more restrictive. But what that means is those larger particles that are conglomerated within a liquid, for an aerosol, for example, are very easily trapped within a HEPA. And because the HEPA is a very, very inhospitable environment, because it's very, very dry, that aerosol quickly gets dried out on the huge surface area of the HEPA, and therefore the virus dies naturally within the HEPA, as well as the antimicrobial coating on the HEPA. So there's multiple actions here, removing that virus before it even gets near the UVC, for example.
I'm looking forward to seeing your results. I think there's a scope of for it, definitely a use. But at the moment, we are sitting with a real problem, and I've got to work tomorrow. So, you work with a little bit of a creep down your back of your neck. And that's why I just wanted to ask the questions directly. Thank you for answering them.
Thank you, Dr. Swart, for those questions. And also thank you, Dr. Swart, for being so influential in South Africa. Connor, just for your information, Dr. Swart was for some of our other leading doctors in South Africa and help from from others in the field of dentistry have been quite influential in setting out some protocols or standards in terms of infection control procedures and so on, particularly during this COVID period now. So thank you very much for your influence, Dr. Swart, from the dental community. We really appreciate it. And kind of just to touch on what Dr. Swart said, and that's what I was reading up a lot about. And sometimes these articles are so scientific, you have to read it about 10 times for it really to make sense. And that's even with my knowledge about lasers and wavelengths and joules per square centimeters and all this kind of stuff. So, but in terms of UVC, using 254 nanometers, the various studies in the past were done on the alpha coronavirus and the beta coronavirus, SARS-CoV-2 and so on, where it did inactivate these viruses. So, but I'm not too sure about what Dr. Swart touched on in terms of it being in different aerosols and so on. But it seemed to be very effective in killing the virus. So I would assume then, because it kills those viruses, it would then also kill this new strand, this COVID-19, in a similar process, because the virus appears to be the similar size, from 0.060 microns to 0.14, 0.15 perhaps. Or in other words, in laser language, we would talk 60 to 140 nanometers in terms of size. So what I also read about, which was quite interesting, was the 222 nanometer, which seems to be a wavelength that is safer if you're wanting to use it where people or human beings are actually walking around or active, because it doesn't have the same absorption as the 254, which can obviously penetrate and harm people's eyes or penetrate the skin layer. But the 222 nanometer doesn't have the ability to penetrate that deep, yet it can destroy the virus. So I think that's probably an interesting wavelength we'll see coming, where it can be used, on work while you're working in a surgery or theatre hospital environment. But then the next thing would be, once again, is what is the surface area that you're treating? And I see they're talking about using it on people, before they go in out of a building. That some of the studies were done, it could take you 15 to 30 minutes just to, treat a human being, work out certain things. But, and you and I did have a discussion about it in terms of using 254 nanometers. Obviously, that is safe in your unit because it's enclosed. Is there perhaps a reason why you would change that wavelength, maybe in the future 222, but no reason, because it's actually this matter, because it's in an enclosed chamber? Did you want to touch on that?
Yeah, so we looked into 220 nanometers as well. And to go back to the previous question, the test results we do have proving that we can kill viruses, we conducted these not in our machine, because we hadn't finished the production of the machine for that component at that time, because we wanted to get something as quickly as possible. And what we had is we had 254 nanometer UV, and it was taking a meter away. So, and we were still able to get 99.997% effective as at killing the virus. And because it goes in with attacking the RNA, it's very, very similar in its destruction between viruses, which is why we are so confident that we can remove COVID-19. And obviously it's an inverse square law. As the further you go away, it's so many times less milliwatts per centimeter squared. So if we manage to get 99.997% at a meter, whereas the air has to pass within 2 centimeters of the bulb, it's going to be on a logarithmic scale more powerful at destroying that RNA. We've done some initial tests and look at some initial papers that say that it's almost as effective to use 220, but what we thought is the downside is the fact that if you look at the bulb, it could potentially damage your eyes, which is why we completely encase it in the machine. So you won't be able to see it anyway. So we actually don't have that downside. So actually we thought we'd use the more effective with more research behind it, 254 rather than the 220. So I don't think we'll look into it in the future, because I don't think there would be an advantage of using 220. Because when you're going to see the bulb, it's not going to be on, because you'll be replacing the filter.
So the only reason people are going to go 220 would vary be if they want to just use it in surgery while they're working and doing procedures, etc. But
yeah, the bulb is exposed. For example, you have some of these units that they use to sterilize entire rooms. Previously, they were just a bulb, and you turn it on a timer. It doesn't go on for 10 seconds. You run out of the room, leave it on for a few minutes, then come back in. Some of those people are looking into doing that with 220 and just having it on all the time. But with a unit like this, it's completely sealed. You can leave it running in the background, like that one was a second ago, and you don't have to worry about being exposed to the UV light.
Good. I don't really have any more questions. I think, as I said, I've read up extensively about this in the last 7 or 8 weeks since this all started, and listened to various webinars, including yourself a couple of weeks ago. And from our point of view, we're really thankful we didn't go for any other system, and that we came across your system and met you. And it's also thanks to guys like Dr. Mark Cronshaw in the UK and so on that did extensive research and webinars with you, which you were involved, and learning all these different systems and how they work. So I must say we're really confident in, and the same we work with lasers. You know, when you change wavelength or you do different treatments, we quite carefully calculate if you're aiming it at a virus or a bacteria, whether it's on the lips or bacteria in periodontal disease or root canal. We understand what's the dose required for the specific wavelength and the time and the area size. So it was a very interesting exercise for me to go and do a lot of homework and dig deeper into this, and obviously to speak to you as well about all these filtration devices, because I'm certainly a lot wiser now than I was 8 or 9 weeks ago. So, and I think besides the coronavirus, just often when we're assisting doctors, particularly training with lasers and so on, the moment you put on a face visor or a mask, you realize what splatter and so on comes on to that screen afterwards. So I think not even looking at COVID, just looking at general aerosol and splatter, and whether it's even blood sometimes and so on, the need for this, particularly in a dental environment, I think there's huge advantages and benefits for it. And I think even in other environments, we've spoken about health centers and movie houses where there's many people and so on. So yeah, I don't think if anybody's got any more questions. I see Dr. Piet van der Vyf has also joined us, and we were chatting earlier today. Let me just see there from Dr. Mark Bowes. On a lighter note, I've missed 2 days sickness in the last 20 days, so air quality in my surgery must have been okay. Also, is there any evidence that the dentists or assistants are more prone to infection over the years due to air quality? I'm not too sure if you answer that. Did you hear that, Connor?
Yeah, I've seen quite a lot of studies that have suggested that improved air quality improves a lot of sort of sick days and things within schools, which just because of the sheer interaction of the number of people. There's quite a lot of those that have been conducted in America. I'm sure we can find some of those and we can share them with all of the viewers on at the moment. But a lot of it, we found that from what we're looking at is the interaction between your reception staff, for example, and all of the people coming in. Just if you have the ability to remove that from the air before it goes to your staff members, I think we will be doing a lot more research into that to find out if we can prove the direct link between having the assistants and sick days off. We're going to be doing a lot more research into that, but there are a lot of papers out there at the moment that are suggesting there is a direct link between those two.
I've also seen some articles where people using not your system but similar systems, people that suffer from asthma and things like that appear to definitely seems to help them. People sleeping better at night and so on. So I don't know how much truth is in all of that. Obviously, it's not related to your system; it's related to similar systems.
For those ones, there's so much scientific evidence behind that, purely about HEPA. So there's a lot of home units that have a large HEPA filter in that can remove pollen and things in the air, and you can dramatically reduce asthma and even stop snoring and hay fever as well. These ones are very, very easy to remove from the air, and there's a direct cause to link for those.
Okay. Thank you, Dr. Mark Bowes, for your question, and also thank you for the input. Yeah, all the input you've also put in helping put these protocols together in South Africa. But yeah, you do some mountain biking, you get some sun and fresh air, so that's obviously also a reason why your immune system is healthier. So one question about what is the warranty on this device?
Yeah, so we give you a 5-year warranty on the structure of the unit and then a 2-year warranty on the electric. We found most units on the market were only offering a 1 year, but because we genuinely believe in it, that's why we're able to offer an extended warranty.
Okay. Just another question, but I think you have answered it. Do we have to wash or vacuum the unit at all? But as far as I know, you just, after a year, when the monitors tell you that those filters are now time to be thrown away, disposed of, you purely dispose of them.
Yeah, so absolutely no maintenance on that front, really. Just wiping the outside of the unit just as you would any other surface in your surgery. And then the pre-filter is inside and attached to the HEPA filter, which means the first part where dust and things are going to collect is on the filter that you're throwing in the bin, not on the unit itself. And then the vents and things in the top won't get contaminated with dust because it is clean air coming out of the top. So there really is not a lot of maintenance to do with this specific unit because of the size of the HEPA filter.
Yeah. Just in terms of the filters too, I think it's the carbon filter in terms of taking out, because I've also done some, with all the reading, some of the materials that the dentists use, like the temporary materials, that they've got some substances in there that potentially can be harmed to breathe in and so on as well. So is that where the carbon filter also comes in, or is
absolutely? So volatile organic components, these are the ones that you can really smell if they're available in the air in large quantities. So it's things like your cleaning products, some bond when you're doing composites, when you're drilling out amalgam, the mercury vapor, which we can detect with this machine in the air actually. So it is when you're doing that, even though most of it goes up your high volume suction, it still is in the air, and the calm filter is very, very effective at removing those from the air. And that actually means, and one of the reasons why we were making this unit in the first place is you can remove the dental smell. So we looked at some studies on why people don't want to go to the dentist, and 50% of people said that one of the biggest things that they fear is the smell associated with the dentist. And with one of these units in the surgery, you can dramatically remove that smell.
Dr. Bowers is asking, what about your loops face shield? Well, we're not really just discussing loops and face shields here, but I mean, you're welcome to quickly answer that question.
So we've developed a face shield that works with loops. We had hundreds of our customers saying, I'm back working at a UDC, but I can't use my loops because no face shield works. Can you do something about it? So we designed a loops system that allows you to wear your loops and a visor at the same time. And what we decided to do was we'd make some magnetic attachments, not just for our own loops, but every brand on the market. We didn't want to say that we're the only ones that get to use these. We want all of our colleagues to be able to use these. And we're currently producing the brackets for any brand completely free of charge. We're going to cover the cost of that, and we can extend that to your customers as well. If you guys need the brackets, we can do them. They simply clip onto any loops, and then our visors click over the top. We've also divided the cost by about 5 compared to any of our competitors. So currently in the UK, a pack of 12 visors is £19.50, including shipping and VAT, which will translate similarly over to you guys. I know some competitors, some of them here are charging £120 for 6. We just want to make these available. It's not something we're making money on. We just want to help our colleagues in a time like this.
Yeah, that's pretty much something that we've done with your system as well. You know, the idea was to take the cost of it from getting it from you guys and then shipping it to South Africa and so on. So, and I also looked at the price of your system, and if you compare it to the competitor's system, I was quite amazed how you were able to. But then obviously just chatting to you afterwards is because, especially during this COVID period, there's more like a service to get for dentistry. So I really appreciate that as well, and that we are also able to actually bring it in, and we are, just making minimal handling fee or something to get into South Africa and supply it to our dentists. And be interesting to see what happens after this initial rush, months down the line from here. And but yeah, we're hoping, we're anticipating, based on your conversation with me, is early July we'll get that first 50 units in. And I know that you guys have been supplying these units. I think you said your production is something like 80 a day, if I'm not mistaken.
Yeah, right? around about that, yeah. And I think we've had nearly 2,000 pre-orders so far.
Yeah. There's another question here. How does the DentAir compare with the Averia Pro 150 air purifier and other units on lexuspress.com for a tenth of the price? So that's interesting, because we have had some guys that have bought things via internet websites, and they said they're also UV, but obviously they would presumably not come with any scientific backing based on the strength of the UVC, the area that they're supposedly disinfecting, and HEPA filters, etc., etc. But maybe you could touch on that.
Absolutely. So it's purely based on the fact that we've got science to back up everything that we're saying. So if you take one of the units you mentioned, the Averia Pro, for example, they have components in that unit which are kind of just tick boxing. So for example, they say they've got UVC, but it's A, uncatalyzed, B, it's a lot lower wattage, and C, the air doesn't directly pass over that bowl. So it's in there somewhere, but it's not doing the same thing that a medically rated device will do. The other thing is, when a lot of these will say that they have a HEPA filter, there won't be any standards on it. So there are loads of different types of HEPA. Anything can be HEPA. So down from an H10, which is around about 70% efficient, all the way up to, as I mentioned before, H15, which is 99.9997. So you'll generally find these ones a lot lower. And also you're going to be able to do a lot less volume with them. They'll always quote on meters squared of the size of a room, but this is not based on a medical or dental situation. This is based on a home situation, which is suggesting 1 air change an hour, not 15 to 20. So what you'll generally find is they will, the list of stats and components it has are more tick boxing rather than actually using. Some of the ones that we've seen, for example, use a single LED of about 500 milliwatts just to say that they've got UVC. Huge wavelength, broad wavelength UVC. It's not going to do anything to kill viruses. The other thing is, I know with the AirVia Pro, you cannot change the UVC bulb unless you have an engineer coming out. So the longevity of the machine may be useful in the short term, but actually long term, you're going to have to do a lot more to that than a different sort of unit where it's all usable, serviceable.
Yeah.
I think that one also is more aimed at kind of the hairdressing market and home environment, which is then they've said, oh, here's an opportunity, let's put it into dental, rather than being built from the ground up for a specific situation.
Yeah. Well, that's what I like so much about your system, and you being a dentist yourself. This was designed for a dental surgery way before we had this whole COVID-19 crisis. So then obviously you guys didn't just sort of jump on the bandwagon for it, and you've designed it specifically for the surgery. So I like that. So just in summary, from my understanding, from what I know, the 5 filtration system, the air comes into the bottom half of your unit. That unit, just by the way, is 80 centimeters high, just less than a meter, and 30 centimeters in diameter, and it weighs about 13 kilograms. Correct?
Yes, it's 15 kilos, but apart from
15.
Exactly.
Okay. And then all the filters and those kind of things, they designed that you don't need a technician or anybody to come out and change it. It is advisable, obviously, when you do change those HEPA filters, that you do put on your normal PPE protection and so on, because that filter is obviously potentially still full of viruses, because it's actually all being collected in there. And you should dispose of that in the correct way as well.
Well, the half-life of a virus, take COVID-19, for example, is about 12 hours. So if you're particularly worried about that, change it on a Monday when it's been sitting there for the weekend. The viruses are not going to still be viable when they're on their HEPA filter. But actually, when you look at it more, because of the flow through of the air, it's an unbelievably in-hospital environment, so they're dried out within seconds. So chances of anything living on there are very, very remote, especially with the peptide antimicrobial coating on there. It's unlikely, but just best practice is to use PPE because we have it in abundance and available anyway. So that's what we recommend.
Okay. And also, am I correct, we chatted earlier, and you're actually supplying these units to some of the dental schools and the hospitals and so on currently in the UK?
Yes, absolutely. So we're working with big open plan spaces, up to 160 chairs on one floor. And the great thing is, because it's all digitally and app integrated, they can work together. So we can actually do any size unit that you throw at us. We can create a sort of combination of them to make it work.
Okay, so you've got a big area like the typical dental school with a large hall, multiple chairs. You could work out the cubic meters and then decide how many units you would like in there, and also at what capacity to run them, because you don't necessarily maybe want to run them at 100% capacity, or are they actually designed to pretty much work 24/7, 100% capacity, or should you be running at 80%?
It's actually designed to run all the time. We've done some testing on it, and the document is in the evidence bundle that we've sent you. We've had it independently checked of what the throughput is. Even though we quote 600, we actually got 685 cubic meters an hour. But that's because once the filters get clogged up after 3 to 6 months of use, you're still going to be getting close to that 600 cubic meters throughput. So we generally work it out with the dental schools. It's 1 unit per chair, because it's more about the amount of aerosol and things that you're producing, rather than the space when you're talking about a room of that size. And it would just mean if you had less than that, you'd be having a slightly louder machine, because it would be working at more like 50-60% rather than 20 to 30%, for example.
Yeah. Okay, so just in summary, for those of you who maybe joined late, the the machine works. It's got 5 filtration parts to it. One is the, won't name them actually in order, but it's the pre-filter, take out the larger particles. You've got a HEPA filter that catches 99.9% efficiency, removing particles below 5 nanometers or 0.005 microns. Or another way you can put it, 99.95% of particles greater than 0.1 micron. So it's pretty effective. Then besides those filters, you've got so it's the pre-filter, HEPA filter, carbon filter, then you've got ionization, and you've got titanium dioxide. So it's all those systems that are actually working before the air comes back out the top of the unit. Correct?
Absolutely.
Okay. And then, as I said, I've double-checked your guys' sums based on our laser knowledge and so on, and seen how much energy is required to destroy the alpha coronavirus, the beta coronavirus, the size of the virus, the strength of your bulbs, the wattage of your bulbs, the area that you're actually using to light up the air going out of there. And I can actually see you've certainly over-designed your unit, which is wonderful to see. So I certainly don't have any more questions. There is a question here. Okay, Dr. Piet van der Vyver, how does the unit compare to the Radic 8? Sorry, you missed the beginning. So I know Radic 8 is potentially your competitor product, so I don't think you want to go and knock another competitor, but I don't know if you can touch on that any way you'd like to.
Yeah, I actually own Eradicate. It was one of the ones we bought when we were in our research and development stages. And it's a very good unit for removing viruses. You know, they have very good figures of 99.997%, for example. But what it's not so good at is being specific to the dental environment. Because of the fact that we are producing so many aerosols and so many particulates within the air, it means that we need a unit which is more specific to our situation. So, for example, with their one, I believe they request that you filter out, you hoover out the filters every week and wash them every month, which we see as a big drawback, which is why we've got the very large HEPA filter, so you don't need to do that. We also looked at it, because in an open room, you can turn over the volume of air that it states on the tin. But actually, in a dental setting, you've got a chair in the way, you've got cabinetry in the way, you've got a person in the way. So actually, if we say 600 cubic meters and you can turn over that amount, you're not going to get completely linear airflow. So you need some redundancy in that. So we can comfortably do 120 cubic meters, which means we'll be doubling up on anything 60 cubic meters. So you have redundancy built in there as well. Because the airflow that we create, we want it to be a floor standing unit rather than a wall mounted unit, just about the airflow as well, just making it more specific to dental.
I think that was another important part too, because some of these units you have to bolt to the wall or particularly stand on the table. So your unit being able to actually be kind of portable, I actually foresee taking it home. You know, so.
Yeah, I have one in my bedroom for that reason, just my fiance with hay fever and things. So one of the prototypes is actually in my bedroom, yeah.
Okay, excellent. And then you are designing a sort of a stand, a mobile trolley for it, something that it will be able to be easily moved from room to room.
Yeah, so especially here in the UK, people are not opening up all the surgeries in one go. So they're acting as a UDC, and then they're moving between surgeries. So we are creating a little thing that literally the machine just sits into, 4 wheels on it, and then you can just wheel it along. So you can move it very, very easy. It's not heavy anyway. You can very, very easily pick it up. And it's not gonna fall over. But yeah, you don't need the wheels, but we are creating that.
Yeah. Okay. Look, it kind of looks like a high-tech, like Bang & Olufsen speaker. So maybe all this.
Okay, it's like an Amazon Alexa, just bigger. What I've been told.
Yeah. Okay. Well, one more question here. Does it matter where your aircon is positioned in relation to the unit?
So you have 2 different types of aircon generally. Sort of a central air system where you've got external air coming into the room, and then you have an aircon unit which is circulating the same air but cooling it down.
Yeah.
Now, the circulating the same air but cooling it down is very, very simple. No, it doesn't really affect it at all because of the throughput of the machine. If you put it directly under, the machine will work a little bit harder because it's got to move the air around, including the air that's being moved by the air conditioning unit. But it's massively overpowered anyway, so it's not going to cause a problem.
Yeah.
If you have air conditioned from a central unit coming in, you have to include the amount of air coming in your calculation of your room size. So, for example, if you have 30-meter cube room, but then at the same time, you've also got 30 cubic meters of air coming in the room every hour in addition to, you then add that to your calculations. But again, because the unit is hugely overpowered, unless you've got a torrent of air-conditioned air coming in, it's very unlikely to cause it. It'll just cause the unit, once again, to operate on a slightly higher level. But it'll do that automatically because of the rack technology anyway.
Okay. Piet, just let me know if you, because Professor Piet van der Vyver was also quite instrumental in putting together some of the new protocols for South Africa infection control. So Piet, if you'd like to just, instead of typing, we can unmute you and it might be easier for you to ask any further questions. And then another question here, Connor, is since the unit attracts air to it, some of the bacteria or virus will hit the surface of the unit. Is the surface treated somehow to kill the virus? Any surface cleaning protocols?
So we looked at putting some coatings onto the unit itself to be able to be bactericidal, but they only have a certain length of longevity. So much like a filter, we can put the antibacterial coating on that because you're replacing it. So that would probably last a year or so, but because you're replacing it every 6 months to a year, it's not a problem. Actually coating the unit itself, it would be great for the first year, but then you lose that. And actually what we find is these coatings tend to degrade and actually then give a more porous surface for bacteria things to go on there. So instead, we make the surface out of cold rolled steel, which means you can use pretty much any cleaning product you want without damaging the unit. So anything that you're doing on your surfaces of your surgery anyway, you can use on this unit. We actually provide a screen protector because there's a touch screen on the top. There's a screen protector that goes on there as well, so your cleaning products won't even damage the screen. So we kind of looked at that.
Okay. Professor Piet, I think you are unmuted if you want to ask any questions verbally.
No more questions, thank you.
You're right. Okay. Just kind of too, one thing, some of the practices have got like, well, 2 or 3 rooms, but they don't have doors. They go into passages and infection control areas and so on, and then into the waiting rooms as well. So calculating the amount of units we would need, you'd obviously have to take the cubic meters of the entire area and work that out because you've got open doors that can't close with doors. But I mean, obviously, I think your suggestion would probably be to put on doors or sliding doors or something for the particular surgery. But in the case that there isn't, we would probably have to work out the complete volume and see if 1 or 2 or 3 machines are sufficient.
Yeah, so in the UK, they've suggested exactly that. If you can add doors to seal off the room, so what you're doing is contaminating the air in that room and then treating it as quickly as possible because you're making it a smaller area. But then at the same time, if it's not possible, treat it like a big open area space like we're doing with the dental schools. So you can include those in the calculations for the size of the room. And again, it'll just make the unit run a little bit faster. So if you want to make it run a little bit slower, put another unit in. So it's a balance between how quiet you want them to be and how many units you want to put in.
Okay. Then, yeah, I think it also, as there's many practices we know of that don't have windows, because often I've heard the comments saying, well, the best way is just open your window and have natural ventilation. But the truth is that many practices don't have windows, you know, and even if they do have windows in some of our countries like Denmark or Norway or Sweden, it's only warm for a few months of the year. UK too, and it gets pretty cold, so you can't exactly just keep your windows open. So I think the importance of the system in many dental surgeries is going to be, you know, highlighted. So I think that's pretty much. We've been going for over an hour, Connor. So I really appreciate your time, and yeah, we'll be chatting more over the next weeks, and we look forward to getting the first systems into South Africa. And I don't know if there's any more questions. Just see one more here. Nice that you including some patient reassurance material. Oh yeah, that's the other thing too. So I think the big thing is some doctors have said, well, just use this time to market your practice, the high standards of your infection control. And many dentists have already been maintaining very high infection controls with gloves and masks over the years. So it seems that many of the practices I go to, and I see them all over the world, some have already maintained always a very good standard. So they don't really have to do too much. It's just sort of, you know, changing gears and stepping it up a bit more. Where obviously some practices have never really had a very good infection control standard. So what's going to be coming with your units is sort of a marketing pack where they can put it on their surgery outside. And I think what we will start doing as time goes ahead is kind of create some sort of awareness for dental practices that have got this system particularly, and kind of use it also in a beneficial for the practice and saying, looking for peace of mind, going to a dental practice, please note that these particular practices have invested in air purification systems. And if you want access to more information and scientific information, please click on the links and that's where you will find it. So that's what we're going to be doing from our side. And I know in your starter pack with the machine, you guys are including those kind of materials for the practice actually to use for their own marketing. Is that correct?
Absolutely. So it'll come with stickers for your doors. It'll come a sticker for the front window, so you can say that your air is protected by DentAir. So a lot of this, people don't like coming to the dentist anyway. So give them an excuse of COVID-19 and they're not going to turn up. So you want to make sure that they know that they're safe. I know that the Eradicate, for example, has virus killer along the front, which is great for showing patients that you're doing something about it. So ours comes with a big sticker that you can put on the front as well that says something very similar. So it says 99.99% effective at killing bacteria and viruses. So it's very, very visual. But at the same time, you can remove it after everyone's forgotten about Corona so that it aesthetically fits into your practice. It'll also come with a metal plaque as well that you can put on your wall, a little bit more official with showing that you're doing something about it. And then we provide all of the e-materials as well, so little things, information about it, cool little videos, and stuff that you can add to your website. So you will want to use this to promote your practice, and we've kind of done all the hard work for you in terms of everything that this unit can do in the eyes of your patient.
And I also saw that there's potentially talk in the UK of having clean air audits from the government. Is that something that is certainly on the cards, or is that just talk?
So at the moment, there hasn't been any talk of it in the UK, but in South Korea, for example, they have to monitor the air quality every day because to actually give their employees somewhere safe to work has to be below a certain threshold for that to be okay. And if it's not, they have to be seen to do something about it. So at the moment, it's not anything said about that in the UK, but chances is, everything becomes more and more regulated. It's likely it'll happen at some point. And our unit will do that and just tell you what it was every day for the last month, and you can print it off the PDF, for example. Okay,
so your unit with the software on it, you can literally sort of do an audit at the end of the month and print out. It will actually give you dates and times and all that kind of stuff of the quality of air that actually tested.
At any point you wish, and it'll give you a live feed, for example, so you can see as you're doing a procedure, your air quality gets worse, and then the unit makes it better. So I really like technology. So any way I can combine some of that in there, I will.
Okay. So will the unit actually detect if you're doing a drilling procedure where there's more aerosol? It'll actually detect that and then increase the negative pressure and volume.
Absolutely. So we use reactive air kinetic technology, which is a combination of volatile organic component sensor and a laser sensor for particulates in the air. So it works out on both of those components. When it senses those increase, the fan speed increases as well. You probably never notice it do anything because as it increases, the fan speed increases. So it's kind of trying to keep your air constantly clean within the surgery.
Okay, excellent. So looks like there's no more questions. And if anybody's getting some final questions, will this webinar be available after today? Yes, most certainly. It's being recorded as far as I know, so you can get another copy of it if you want. Also, if any of the listeners would like any more scientific information or literature, we will gladly forward that to you with our links. And I know, Connor, as soon as you're getting more information, you're forwarding it on to us real time pretty much so that we keep up to date of what's going on. So that's pretty much it. And I'll touch base with you, as we have been, and pass on any information to our doctors in South Africa and Denmark, Norway, and Sweden, and Mauritius as well, areas that we operate in. And so if anybody's got any more questions, please just email them to SciVision and we'll answer them if we can, or if I can't, we'll speak to you, Connor, and get some more information. Thank you very much. I appreciate it. I'll chat to you on the phone. Okay. Cheers. Good evening, everyone.